Welcome to Spring LIB.
All right, hello. In this question, we're going to discuss what happens when we have a collision between two objects. It doesn't necessarily matter if they're the same weight or different weights, but let's go ahead and discuss this. So which of the following is true? We're told that the collision is completely elastic, which means there's no energy lost. So let's go ahead and just define that term first. In an elastic collision, energy is conserved throughout. Or another standard way of saying it is that our initial and final kinetic energies are the same for the two objects. That's the definition of elastic. And then we're told that there are no external forces acting on a system, which means momentum is conserved. Momentum is not conserved when we have external forces acting on the system. So that's the information we're given. Let's go ahead and look at these statements. I'm going to label them 1, 2, 3, so on and so forth. The total energy of the system remains the same throughout the collision. That is true. Because it's an elastic collision, energy is conserved throughout the collision. That's at every individual point. It's not just before and after the collision. It's through the entire thing. 2, the total energy of the system before and after the collision is the same. That is also true. Very, very similar thing. Our kinetic energy before and after is the same. 3, the total kinetic energy is the same throughout the collision. That's true. During a collision, you can look at any point of the collision, any moment in time, and conservation of energy and momentum still apply. 4, the total momentum of the system remains the same throughout the entire collision. That is also true. So momentum always is conserved, regardless of if it's elastic or not. The total momentum of the system is only the same before and after the collision, but not during. That is not true. So conservation of momentum occurs at all different timescales throughout the entire collision. And then let's see, number 6, the momentum of each object remains the same throughout the collision. That's not true because we know that the momentum of the system beforehand is equal to the momentum of the system after. If we have two objects, 1 and 2, they're not necessarily going to have the same momentum throughout, but the total momentum throughout will be the same. So 6 is going to be false. 7, during the collision, the impulse on the lighter object is greater than the impulse on the heavier object. So we know impulse is equal to a change in momentum, which is equal to some force times some time, or mass times our change in speed. Notably, because of Newton's third law, this force here is going to be uniform or equal for both objects. So number 7 here, during the collision, the impulse on the lighter object is greater than the impulse on the heavier object. That's not true. The impulse on the lighter and the heavier object is going to be the same. So 8, during the collision, the impulse on the lighter object is less. That's not true. 9, 9, during the collision, the acceleration of the lighter object is greater than the acceleration of the heavier object. That's true because of Newton's second law. We know that because force equals mass times acceleration, if we have a smaller mass, we're experiencing the same force. So that means that if this is constant and this goes down, our acceleration must go up. And so the lighter object will have a greater acceleration than the heavier object. Number 10, during the collision, the acceleration of the lighter object is less than the heavier object. No, we just discussed that. 11, during the acceleration of both is equally. That's not true because their masses are different. Moving on to number 12 here. During the collision, the force on the lighter object is greater than the force on the heavier object. That's not true. They experience the same average force because of Newton's third law. 13, during the collision, the force on the lighter object is less than the force. That's not true, again, because of Newton's third law. Last one, during the collision, the force on the lighter object is equal to the force on the heavier object. That is true, again, because of Newton's third law. Equal magnitude, opposite in direction, notably. Hope that all made sense. I hope that helped out.